Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in our today's mathematics session. So I think you are all ready with your books and pen, isn't it children? So let us start our session children now. So today we are going to learn about algebraic expressions. So by the end of this session you will learn basic concepts of algebraic expressions, types of algebraic expressions, addition of algebraic expressions and subtraction of algebraic expressions. Can you identify the image shown on your screen children? Yes, it is a square. And children, how many sides does it have? You are right once again. A square has 4 sides. Now what do you know about the sides of a square children? Yes, you are absolutely right. All the 4 sides of a square are equal. So since we have only one square, I have only 4 sides for this square. So in fact any square will have only 4 sides. Now let us see if we take 2 squares children. Now take a look at the screen now. We have 2 squares. Now children, can you say how many sides will be there in these 2 squares? Yes, you are right, 8 sides. Why children? Because we have one square, so 4 sides, plus there is another square, so another 4 sides. So 4 plus 4, 8 sides. Now I will write this 8 as 4 into 2. Got it children? I can write 8 as 4 into 2. And here this 4 is number of sides. And there are 2 squares, I am writing 4 into 2. Got it children? Now take a look when we have 3 squares as shown on your screen. So we have 3 squares and how many sides will be there children in all? Yes, we will have 12 sides children, because 4 for this square plus 4 for this. 4 plus 4, 8 plus 4 sides of this square. So overall total number of sides will be 12. Now I am going to write 12 as 4 into 3. Why again 4 into 3 children? Because number of sides of a square is 4 only, into there are 3 squares, so into 3. So 4 into 3 we will get it as 12. Suppose if we are going to have say 5 squares children. Now how many number of sides will be there in all? You are right once again children, it will be 20 sides. And I am going to write 20 as what children? Yes, we are going to write it as 4 into 5. Did you understand why 4 into 5? 4 is the sides of one square, that is 4, number of sides of a square, into 5 squares are there, that is why into 5. Now let us quickly write down children what we have noticed. When one square is there, there will be 4 sides, I am writing it as 4 into 1. When there are 2 squares, there are total 8 sides, I am writing it as 4 into 2. Similarly for 3 squares, 12 sides, we are writing it as 4 into 3. And finally when we have 5 squares, we have 20 sides overall, and I am writing it as 4 into 5. Now children, do you notice any pattern here children? Yes, if you notice here, this 4 is constant throughout all these images, isn't it children? So whether it is 1 square or 2 square or 3, 5, whatever it is, here this 4 remains the same, or I can say it is constant. Got it children? Now whereas if you notice the other part, that is 1, 2, 3, 5, etc. Now this, what is happening to this? Yes, it is increasing. So that means here this is nothing but number of squares. So number of squares are increasing it, right children? So if we have 1, then 2, then 3, then 5, like that. So it is increasing. Now if you move from this way, obviously it will be decreasing it, right? 5, 3, 2, 1. So that means there is change in this case, whereas this one remains the same, whereas this part remains changed every time. Now let us see the total number of sides children. Even if you notice the total number of sides 4, 8, 12 and 20, it also increases or changes accordingly. So children, we have seen that one quantity remains the same whereas the other quantity keeps changing. Isn't it, children? Now let us define let us generalize the situation, children, here. So how many sides are needed for 10 such squares, children? Like for example, there are 10 such squares like we have seen here. If I am going to have 10 squares, then total how many sides are there? Now the number of sides for 10 squares will be 4 into 10, which is 40 sides, children. Isn't it? So when there are 5 squares, it is 4 into 5. When there are 3 squares, 4 into 3. 2 squares, 4 into 2. Like that, when we have 10 squares, it is 4 into 10. Total number of sides will be 40. I hope you understood the children, right? So let us generalize this, children. Suppose I have, we know that the number of sides of a square is 4. Now let us assume the number of squares be s. So it may be 5 squares or 10 squares or 20 squares or maybe 100 squares also. I don't know. So that's why I am assuming it to be some s, which is again a number itself. Now what will be the total number of sides in this s squares, children? Yes, it is 4 into s. That is number of sides of a square 4 into the number of squares s, and 4 into s we write it as 4s. Now in this 4s, this 4 is called a constant. Understood, children? Here 4 is a constant. Now whereas if you consider s, it is called a variable. Now what is actually a constant and variable? Let us see, children. So a constant is a quantity whose value is fixed, children. Like here if you notice 0, 1, 2, 3, so on, or maybe minus 1, minus 2, minus 3, so on. So whose values are fixed, they are called as constants. Now variable means it takes different values and its value is not fixed, it keeps on changing. And we denote the variables as A, B, C, D and so on, the letters in English alphabet. Okay, children. Now let us see where we come across this constant and variable in our daily life situation, children. Let us see a few examples. So first we will see constant. Length of your room. Now see, children, the length of your room, will it be changed any day? No, it remains same. Isn't it, children? So we call it as a constant. Not only that, if you take the number of days in the month of May, now every year May month will have the same number of days. Isn't it, children? Now let us see the example of variable in our daily life. The temperature in a day. So one day it may be very hot, the other day it might be very cold or rainy, etc. Isn't it, children? We see a lot of changes in temperature every day. So it is not fixed, it keeps on changing. So temperature in a day is an example of a variable. And age of a person. Now even if you consider the age of a person, it keeps on changing. So every day your age will be changed, children, isn't it? So children, the total number of sides in s squares is 4s. Now this 4s, we generally call it as an algebraic expression. So let us take an example, children, how to frame an algebraic expression. Okay, children, let us see the example. Ravi scored 8 marks more than Raju. Find Ravi's marks. Now read the question carefully, children. Here Ravi scored 8 marks more than Raju. So here we are finding Ravi's marks. First of all, Raju's marks are not known to us. Then how to find Ravi's marks? So here this quantity is unknown to us. Even though this is a number, but we don't know exactly how many marks Raju has got. So we assume that to be some variable. Like I'll assume Raju's marks as P. So I have taken it as P, children. You can use any letter in English alphabet, that it can be A or B or X or Y. So I am taking it as P. So here Raju's marks are P. Now what is given to us? Ravi's marks is 8 marks more than Raju. That means Raju's marks plus 8. So here Raju's marks are P. So we are substituting P plus 8. Now this is the marks scored by Ravi. Now this one, whatever we obtain, P plus 8, is again an algebraic expression only, children. So an expression can be a single term or a combination of terms connected by either plus or minus. So here you can notice 4s, this is the algebraic expression, it contains only one term, but whereas here in this case it has two terms separated by what? A positive sign. It can be negative also. Suppose if Ravi gets 8 marks less, then we would have got P minus 8, isn't it children? So we may get either a plus sign or a minus sign. So this is the framing the algebraic expression, children. Now let us see few more examples of algebraic expression, children. So 11z, 3x minus 5, 2p plus 3, y square minus 3y plus y, 9x plus 5y minus 18. So these are all examples of algebraic expressions. If you notice the first one, children, here it has only one term, whereas if we consider the second one, it has, yes, two terms, and the remaining one, if you see, how many terms are there, children? Yes, there are three terms. So an expression that is algebraic expression can have one term, may have two terms, or it can have three or more than three terms also. So children, we have learned what is an algebraic expression, and we have also learnt the examples and also how to frame an algebraic expression. Now let us see what are like and unlike terms. Let us see, children. Now consider here some algebraic expressions as shown. Now if you see these two algebraic expressions, do you see anything common in these, children? Yes. Both, that is 11x and 3x, has same variable x. So I'll write it as separate thing, children, 11x and 3x. Now still, do you find any such pairs, children, where there is same variable with the same power? Yes. If you notice, minus 5z cube and z cube both have same variable with the same power, isn't it? So I'll mark it as a separate one again, these two. Now we are left with two more quantities, that is 7ab square and minus 11a square b. Now in these two we have same variables ab and ab, but if you see their exponents, they are different. Here a power is 1, but here in this case power is 2. Here b's power is 2 and here b's power is 1. So they are different. Now if you consider these terms, that is 11x and 3x and also 5z cube and z cube, they are called like terms. And 7ab square and minus 11a square b are called unlike terms. Now let us see what is meant by like terms. So terms which contain the same variables with same exponents are called like terms. So if you notice these two, they contain same variable with the same exponents, see 3 and 3, and here also same variable and exponent. When nothing is there, only x is there, that means the power is, or the exponent is 1 here. Here also exponent is 1. So such terms are called like terms. Now what do you mean by unlike terms, children? The terms which are not like are called unlike terms. So here these two are not like. Why? Because variables are same, but their exponents are different. So that's why we call them as unlike terms. Got it, children? Now children, let us see an algebraic expressions bank here, children, which contains lot of algebraic expressions. Now they are coming out one by one. Let's see, children. So the first one I see minus 7q, the second one 3p square minus cube plus 4, third one 3c plus 4d, and the next one is x minus 2y minus 3z. So it has three terms, so I am writing just below this. And the next one is 5x plus 1, it has two terms, I am writing just below this, so that these two examples have only two terms in that. And then I have another one, that is 2b, a single term, I am just placing below the other single term algebraic expression. And finally I can see another expression having 4 terms. Now children, if you notice the first one, minus 7q 2b, they have only one term, isn't it, children? They are called monomials. Now whereas if you consider the second one, that is 3c plus 4d or 5x plus 1, they have two terms. So we call it as a binomial. and the third one, that is 3b square minus q plus 4 and x minus 2y minus 3z, they have 3 terms each and we call it as a trinomial. And the last one, it has 4 terms. We call it as a multinomial. Now these all monomial, binomial, trinomial, multinomial, these are called the types of algebraic expressions. Now let us learn about these types, children. So the first one is a monomial. Algebraic expressions with one term are called monomials, whereas algebraic expressions with 2 unlike terms are called binomials. Then we have trinomial, which means algebraic expressions with 3 unlike terms are called trinomials. Now let's see about multinomial. Algebraic expressions having more than one unlike term are called multinomials. So that means even binomials, trinomials are also multinomials only, children. Okay, but these multinomials, if they have only 2 terms, we call it as a binomial, and if a multinomial has 3 terms, we call it as a trinomial. So children, we have seen about the types of algebraic expressions. Now let us learn about the degree of algebraic expressions, children. So consider here the algebraic expression 9a square b cube. Now if you notice here, a has 2 as exponent and b has 3 as the exponent. Now these two, you already know they are called as exponents. Now the sum of all exponents of the variables present in a monomial is called the degree of the term or simply the degree of the monomial. So since only one term is there, so how do you find its degree of this term or the given monomial? We need to add all the exponents of the variables. So here degree of 9a square b square will be how much, children? Yes, here the exponents of the variables are 2 and 3. So we add those exponents, that is 2 plus 3 gives us 5. Hence I can say that the degree of 9a square b cube is 5. So this is how we find the degree of a monomial, children. Now let us see the degree of a constant term. Now consider 6, it's a number, right? A constant. Now we have already learnt laws of exponents. In that we have seen a power 0 is always 1, isn't it, children? Now 6 can be written as 6a power 0, because a power 0 is 1, 6 into 1, again you will get back 6 only. Now here the degree of 6 is now, what is the exponent of this variable a, children? 0. Therefore degree of 6 is 0. That means I can say that degree of a constant term is always 0. Got it, children? Not only 6, you can take any constant. Like if I ask you what is degree of 10, it is simply 0. Even if I ask you what is degree of 5, then also the answer is 0. Got it, children? Now let us find the degree of algebraic expressions. So consider the algebraic expressions shown on your screen, children. The highest of degrees of all the terms of an expression is called the degree of the expression. Now let us understand with an example, children. So for that, I am just using a tabular form here. I will write the expression here. Then let us see the terms here, the first term, second term, third term and highest degree. So we will find out for the first one, children, that is 6xy minus 2 by 3 x cube y. This is the expression. Now here what is the first term, children? Yes, 6xy. Now what is the degree of this 6xy? xy, that means x power 1 and y power 1. Therefore the degree of the first term is 2. Now what is the second term, children, here? Minus 2 by 3 x cube y. Now what will be the degree of this one? Here x to the power of 3 and y to the power of 1, that is 3 plus 1. So 4 is the degree of the second term and we don't have third term, we don't have to worry. Now out of these two terms, right, which is having the highest degree? Second one. What is that? 4. So highest degree is, yes, 4. That means the degree of this algebraic expression is 4. So first we will find out the degree of each and every term, and whichever is having the highest degree, then that is its degree of the algebraic expression. So the degree of 6xy minus 2 by 3 x cube y is 4. So let us see the second example, children, now. So here the first term is AB square. Now what is the degree of the first term? Yes, 3. Now what about the second term, children? Yes, here the power is 2 and 2, so 2 plus 2 is 4. Now we have a third term and its degree is 7, 3 plus 4. Now out of these 3 terms, third term is having the highest degree, that is 7, isn't it, children? So write down the highest degree. Now whatever is highest degree here, that is 7, that becomes the degree of the expression. So here 7 is the degree of the given expression. So children, now let us see what is meant by the standard form of an algebraic expression. So in an expression, if the terms are arranged in such a way that the degrees of the terms are in descending order, then the expression is said to be in standard form. For example, if you consider, children, 2x square minus 5x plus 10. If you notice here, the degree of this term is 2, whereas this is 1, this is constant, so 0. So they are in descending order, right, children? That is decreasing order. Then this expression is said to be in standard form. Let us take one more example, children, here. 3y square minus y minus 9. Now in this case also degree of the first term is 2, second one is 1, and the last one is 0. So they are in the descending order. So it is said to be in the standard form. So let us see finding the value of an expression. So for that we will take an example. Find the value of 2x square minus 5x plus 10 if x equal to 1. Let us see the solution, children. So for this, what we are going to do is, we are going to substitute the value of this variable. So here we are going to find the value of this if x is equal to 1. That means the value of the variable is 1. So for that, what we do is, whatever the value of variable is given, this value, so here in this case it is 1. So this 1 I will be substituting in place of x in this algebraic expression. So put x equal to 1 in 2x square minus 5x plus 10. So this will become 2 into 1, sorry, x square is there, so I get 1 square minus 5x, that means 5 into 1 plus 10. Let us simplify this, children. So we get 2 into 1 minus 5 plus 10. So on further simplification, you get 2 minus 5 plus 10. So it is 2 plus 10, 12 minus 5, you get 7. So the value of the given expression is 7. So children, now we will move on to the important concept, that is addition of algebraic expressions. Let us take an example, children, now. So we can add 2 terms if they are like terms, or I can simply say that we can add only like terms. Unlike terms cannot be added. So this is the important rule you need to remember, children. So let us take an example. Add 2x square plus 5x minus 8 and 10 plus 3x square. So first we are going to write the expression in standard form. That means in the descending orders of its degree. So 2x square plus 5x minus 8, and this becomes 3x square plus 10. And in the second step, we are going to write one expression below the other expression. How? So that the like terms will be one below the other. So here 2x square, then below that 3x square, and in the second algebraic expression we don't have x term. So we are leaving it off and writing the only constant below the another constant. Now what are we going to do? Yes, in the third step, just add the like terms column wise and write the result. That means I am going to add minus 8 plus 10. So minus 8 plus 10, negative number and a positive number. So you need to subtract. So you will get 10 minus 8 is equal to plus 2. Then since we don't have any x term over here in the second expression, so we write down the first expression as it is, that is 5x. Now if you look at these two, we have 2x square plus 3x square. So in such case, we just add these two coefficients, that is 2 plus 3. How much, children? 5. So we write it as 5x square. Hence, on adding these two algebraic expressions, you get 5x square plus 5x plus 2. And children, this method of adding we generally call it as column or vertical method. Got it, children? But we can add these two expressions in another way also, children. Let us learn that also. We call it as row or horizontal method. Let us see now. So we are going to write first algebraic expression plus the second algebraic expression in a single row. Okay. Now what are we going to do? We are going to rearrange the terms by grouping the like terms together. So I am going to bring these two like terms together, plus we have only one x term and minus 8 plus 10. I am writing it as separately. Now 2x square plus 3x square. Now what are we going to do now? Yes, simplify just the coefficients. So here 2 plus 3, 5. So we get 5x square, and x is only 1 here, so that is 5x. So I am writing it as 5x as it is. Minus 8 plus 10 is nothing but plus 2. So I am writing it as plus 2. Got it, children? Now children, let us learn about additive inverse of an expression. So 8 plus which number gives you 0, children? Yes, you have already learned, right? 8 plus minus 8 is always equal to 0, and we say minus 8 is additive inverse of 8 and 8 is additive inverse of minus 8. Like that, if I take for any algebraic expression also, there is an additive inverse. How? For example, if I take 5x to 5x, or which algebraic expression if I add I will get 0? Yes, absolutely right, minus 5x. Now when I add plus 5x and minus 5x, I get 0. So I say minus 5x is additive inverse of 5x and 5x is additive inverse of minus 5x. Let us take another example also, children. Now to this algebraic expression, which one if I add I get 0? So for that, I just simply add, so this number itself. See, here plus is there, it becomes minus. Here minus is there, it becomes plus. Here plus is there, it becomes minus. So you need to just change the symbols, plus to minus and minus to plus. Now let us see subtraction of algebraic expressions, children. Let us take an example. Subtract 5x plus 7y minus 4 from 11x minus 2y plus 10. So again, first we are going to write one below the other, children, okay, as shown on your screen. Okay, so that the like terms will come one below the other. Now in the second step, we are going to change the sign of each and every term of the expression, children, that to the second row. Here if you notice, here we have plus 5x, so it will become minus. Here we have plus 7y, it will become minus 7y. It is minus 4, it becomes plus 4. Now this is the most important step, children. Particularly we need to follow this in subtraction case only. Now in the third step, we are going to add the like terms and write the results. So here what are the like terms? Here both are constants. So 10 now plus 4. Now we are not going to bother about this sign. 10 plus 4, 14. And then here minus 2y minus 7y. It will be minus 9y. And here 11x minus 5x. You get 6x. Hence, on subtracting these two, I got 6x minus 9y plus 14. Now this method already we have seen. We call it as column or vertical method, isn't it, children? Now we can do the same in horizontal or row method. Let us see that also. Now write the expressions as shown, separated by a minus and right. So from this we are subtracting this expression. Okay, don't forget to write the brackets, children, it's very important. Now in the next step, just open the brackets. So here these terms will come as it is, no change. But when I remove the bracket here, now we need to multiply each and every term with this minus n. So minus into plus minus, so minus 5x, minus into plus, again minus 7y, and minus into minus plus 4. So first we need to add the like terms. So 11x and minus 5x, and then we are going to add minus 2y and minus 7y. Then last we are going to add the constant. So on adding that, you get how much? 11x minus 5x is 6x, minus 2y minus 7y minus 9y, 10 plus 4, you get 14. So I think you understood even the row or horizontal method for subtraction, children. Till now we have learnt about some basic concepts of algebraic expressions, and also we have seen about types of algebraic expressions, and also we learnt how to add or subtract any two algebraic expressions. So before we end our session, let us quickly recap what we have learnt in our today's session. A variable takes different values and its value is not fixed. An expression is a single term or a combination of terms connected by the symbols plus or minus. Terms which contain the same variables with the same exponents are called like terms, and algebraic expressions with one term are called monomial. Algebraic expressions with two unlike terms are called binomials. Algebraic expressions with three unlike terms are called trinomials. Algebraic expressions having more than one unlike term are called multinomials. Degree of a constant term is always 0. And also we learned that the highest of degrees of all the terms of an algebraic expression is called the degree of the algebraic expression. So children, I would like to give you few problems as assignment. You please do it at your home and submit to your teacher. So children, with this we have come to the end of digital class. So we'll meet in our next class. Until then, goodbye and take care.